Cool, and on to the next question, which is going to be a calculus question, an optimization question, but we've done, I think there's one like this similar in yesterday's paper. So the first part is they want you to try and show how you can form an equation. Second part, they want you to use differentiation and find stationary values and whatnot. So let's do the first part, which is we have to show that the area of this whole inside of the track is the same as this. What they've given us is some information about how the track works. It's got two straight edges of x and two curved edges that have a radius of r, and the perimeter is 400 metres. So if we go ahead and try and form an equation, first of all, we know that we're going to have 2x, and x for each of the straight edges, and we're going to have pi r squared, which is the circumference, 2 pi r, which is the circumference of a circle, because I've got two half circles here, one there and one there, and if I put them together I'm going to get a whole circle. So that's going to be the same as 2 pi r, and all up that's the perimeter, and all up we know that equals 400. So 2x plus 2 pi r equals 400. We've got to get an equation for the area, and you can see the area is in terms of r. So when you go back to our equation here, you see we've actually got an x in there, so we need to get rid of the x. So what we're going to do is we're going to write x in terms of r. So later on when we substitute, we can substitute for x by using this expression. So if I just rearrange that quickly, I'm going to get 2x equals 400 minus 2 pi r. Oh, we're in a space. Sorry. At any stage you could divide everything through by 2. But we'll do it now anyway. So x equals 200 minus pi r. Cool. So we've just written x in terms of r so that later on we can use that. So you could either do that step now or you could do that step after the next part, which was to use what we've got to do an expression for the area. So if I'm just going to start again just so I can show you how this works. If I just use the diagram here to work out the area, that would be the same as doing this part here in the middle and then doing the area of the circle on the outside. The part that's in the middle has got a width of x and it's got a height of 2r. Okay, so the area in the middle would be 2 times 2x times r, okay, or 2xr or 2rx, however you want to write down. And then the area around the outside would be pi r squared. It's just the area of a circle. Okay, so that would be the area. So let's say you did this and you go back here and go, oh, okay, this is not quite right. This is supposed to be all an r, and I've got an x here. So at this stage you could then go back to the perimeter and work through this. I've done that first just because I had that insight to know I needed to get an expression for x that was in terms of r, but if you did it this way, at this point you're going to have to do something to make this all in terms of r. So what I can do now is I can substitute in, leave the 2r, substitute the x in this part here, so 200, this part here, so 200 minus pi r in there, and leave the pi r squared, like that. And then I can expand it out. So I'm going to get 400r, I'm going to get minus 2 pi r squared plus pi r squared equals a, and if I tidy that up, I'm going to get 400r minus pi r squared. Okay, for the next part, we're going to do this whole stationary value thingy again. And I mean, it's pretty similar to what we've done before. The only thing here is they've said this weird thing, which maybe was a bit confusing, which is show that when A has a stationary value, there are no straight sections in the track, and then determine whether this stationary value is a maximum or minimum. So you might think, oh, that's a little bit strange. But my advice to you is just, just start solving it and let's just see what happens. So if I start off with the area formula, I should write in a better place where I can write the whole thing out on one line. I'm sorry. When I differentiate that, so dA, I'm going to get 400 minus 2 pi r. So the important thing about differentiating is that you're differentiating with respect to a variable, and so in this case here the variable is r. So here I've got 400r, that's r to the power of 1, so I just do that whole power, take the power off, so it becomes 400, and here I'm differentiating with r squared, so that pi is like a number like 3 or something like that. So you leave it there, multiply by 2, and then take a power off, so you get r. So that's my derivative there, 400 minus 2 pi r. And I need to show what the r value is when I solve that. So we know that stationary values is when the first derivative, which is the gradient function, equals 0. So I'm going to set that equal to 0, and then I'm going to rearrange it. So I'm going to get 400 equals 2 pi r, like that. And I'm just going to leave it just for a second about why that shows you that there's no straight sections in the track. You might already start to figure it out. And I'm going to go straight to the next part, which is to do the second derivative to check if that's a maximum or minimum. So remember, all we do for the second derivative is take what we got for the first derivative and derive it again. So when I derive 400, I get 0. And when I derive 2 pi r, I get negative 2 pi. So that value there is less than 0, so that makes it a maximum. Okay, so we've done most of the question now. We've found the stationary value, but they actually want us to show that that shows that there's no straight sections in this. So if I go back to where I left off the derivative before and make r the subject, r is going to be 400 divided by 2 pi. Okay, so the radius is the same as the perimeter here divided by 2 pi. So what does that mean? That means it's a circle, right? Because if you had a circle and you had a radius r, then the perimeter is the same as 2 pi r. And we've already been told that the perimeter of this whole thing is 400 metres. Okay, so therefore that shows us that would have a circle. Okay, so I always check the assessment schedule after I've finished doing my video, just to check that I'm right. And so in the schedule that I've put online for you, what it has done is after this point here, so that r equals 400 over 2 pi, it's then said that there's no x in there, which means that there's no straight sections. And I finally worked out what they did. All they've done is actually gone back to the original equation we had before, which was x equals 200 minus pi r. So when you substitute this whole shebang into there and simplify it, you get x equals 0, which shows that there's no straight edges.